Hello everyone and welcome to this section. In this section, we're going to apply the region of interest masking that we have done before, along with the Hough lines transformation to actually detect lane lines within an image. Okay. All right, let's get started. So let's run the first section, just importing all the libraries. And then here, we're gonna show the image. So this is kind of, like a very simple image. And my objective here is to detect these two lines within an image. Okay. All right. First step is that we're gonna take the image and we're gonna convert the image into grayscale. Again, we have done that several times before. I hope you guys are experts by now. So I took the image C, which is image color. I'm gonna apply color underscore BG RGB to gray, and that will gonna simply obtain the image in grayscale. And let's plot it. Let's see what it looks like. So that's again my image in grayscale, and if you guys can see, the dimensions of a colored image is 540 by 956, and it's 3 dimensions. And here we have 540 by 956, which means just a single kind of dimension, which makes sense because it's a grayscale image. All right. The next step is we're gonna do a canny edge detection, but before canny, what we're gonna do Gaussian blurring. We're just gonna take the image, blur it a little bit, all right, and then we're gonna apply canny on it afterwards. So what I'm gonna do, we're gonna use OpenCV cv2.Gaussian blur. I'm gonna provide the image along with the dimensions of my kernel, okay? Which again, here I'm just going to use 7 and 7. You guys can, again, try all these parameters are adjustable. You can get better or worse result than this, okay? That will return the image blurred, and then here we're going to plot the blurred image. Let's run it. And you guys can see here, the image is a little bit blurred. Again, it doesn't show, it's showing here as kind of, like colors because I didn't show the color map. Okay, here if you specify color map as gray, it will show the grayscale image, okay? All right. The next step, I'm going to apply again canny edge detection. Again, you guys are experts by now. cv2.canny. And then going to do the image blurred. That's my image. I'm going to apply the threshold. So I'm going to define the threshold low and threshold high to indicate, like 10 or 200, for example, just indicating the threshold values. Okay, and then I'm going to plot the image canny afterwards. Let's run it. All right, and that's my image in a kind of a canny form, which kind of edge detected form. As you guys can see here, these are kind of my 2 lanes that I'm looking for. And obviously I'm not looking for any of this. I'm not interested in looking for the lane lines in the sky or here in the back, with all the trees and so on. So I need to get rid of this. I want to get rid of even this because, it's a lane, yes, but it's kind of outside my region of interest, okay? All right. The next step is going to define my region of interest. Again, we have done that before. Let's take a look. So here I define my vertices, as this, which is simply, I'm going to pick, first of all, I'm going to pick a couple of points. First, I'm going to pick point 20 and 460, which is indicating my the value of, here I'm just going to go to, let's say, around 20. I'm going to go down to around 460 approximately. So it's just going to be somewhere in here, okay? And then I'm going to select 340 and 300, which is, again, I'm going to go again 340, which is somewhere in here per se, and 300, which is this point approximately, which again, I'm going to be selecting, like this region. Obviously, I'm going to have another point, which is have the same y-axis, which is pretty much the same this. That's why there's 300 and 300, because these 2 points have the same y value, but it has different x. It's shifting in the x direction. And that's why you would see the x is around 450, 460 approximately this point. And then I'm going to select the last point, which is somewhere in here. I'm going to select 740, which is again 740 and 460 going down, which is kind of this 4th point. And that's pretty much my region of interest that I'm interested in. I'm gonna skip anything else. I'm not interested in any of them. Okay, that's the first step. Second step, I'm gonna create a black image. And that's why I'm gonna call again numpy.zeros_like. I'm gonna use image gray just to get the dimensionality of my image. I'm gonna create a mask, all right? If you guys recall, this is a mask with all zeros. What I'm gonna do is I'm going to define in my region of interest that I defined, okay, I'm just going to set it, put ones in it, just define, like bright colors in it or light or white color in it. So I'm going to use my mask. I'm going to use the command cv2.fillPoly, fill polynomial. I'm going to define my vertices, which is I've had here. I'm going to put 255 indicating number 1 or white colors within the region of interest. Perfect. Afterwards, I'm going to take my image, which is my original image, or a grayscale image. I'm going to use my mask, which has, again, all zeros and some ones in here, do bitwise ending that will specify or indicate my region of interest. okay, which is again my masked image. Okay, then I'm gonna show my masked image. Let's run it. All right, and it looks perfect. You guys again can try different points. You guys can, if you want to extend the region of interest to make it, for example, here between this corner and this corner, you can do it. But this kind of, like the lane is a little bit shifted. That's why it's very difficult to just go from here to here. You can still do it, obviously. But again, the image is kind of a little bit tilted or shifted to the left. All right. And then afterwards, what we're going to do here is going to do masking between the image canny and the mask. All right, let's run it. And that will show me pretty much what's left, not from the original image, but actually from the canny values. So that's pretty much what I'm looking for. If you guys recall, this pretty much looks exactly the same as we had before when we were detecting lines using Hough lines in a simple calendar, if you guys recall from previous sections, or in just that simple image that has a vertical and horizontal line. Okay, that's pretty much all what I need. Okay, so what I could do moving forward, I was just going to use my Hough lines, okay, to simply detect all the lines. So I'm going to use cv2.Hough lines, but here I'm going to use what we call probabilistic Hough lines. Okay, that's why I use Hough lines P. Okay, again, it's I'm not going to dig into the mathematics of it, but the whole idea is just going to give me like kind of a vector that with lines in it, which is instead of using cv2.Hough lines, we're going to use Hough lines.p, which is kind of probabilistic form. Okay, you guys can read into it a little bit more if you wanted to get, but here we're just going to use it to detect or indicate all the lines within the image. All right, so here I'm going to define some parameters here, rho, which is the distance, resolutions, and pixels. I'm going to define theta. If you guys remember how many times we're going to be rotating, here I'm going to be rotating angular resolution of 1. Again, the threshold, which is the minimum number of votes, so I'm going to set it to 40. You guys, again, all these are tunable parameters. Here I'm going to define the minimum line length, which is the minimum number of pixels to indicate a line, which is 100, and maximum line gap, which is 50. Which is simply maximum gap in pixels between connecting line segments. All right. Okay. Let's run it, and then what we're gonna get here out of this, gonna get lines, and then what I'm gonna do here, I'm gonna create again an empty image. Okay, we'll call it line image, and what I'm gonna do is I'm gonna take the empty image and draw all the lines on it in a simple form. So what I'm gonna do, I'm gonna create a for loop. Okay, we're just gonna call it for line in lines again. Lines is simply the number of lines, or the actual indices of the line. Again, x, the different points, the start and ending point of all the lines that has been detected within an image. Okay. All right. So what I'm going to do is I'm going to create again this for loop to loop on all lines, and then every time we're just going to go and grab x1, y1, x2, and y2 within my line, which is I grabbed here within the previous for loop. And every time we're just going to go take my line image, which is kind of a blank image, and put all these points in there. Put the point start point, put the end point, and afterwards I'm going to put the color. And here I'm going to simply specify the color, which is here I'm going to specify like a green, red, or whatever color we want it. Okay, and then afterwards we're going to return the lines. This is simply, we're going to just create on the line image, which is again blank image. I'm going to draw all the lines that I've had before. Okay. All right, let's run it. And here I just wanted to show the lines as well. That's why I indicated as well. I tried to plot the lines, which is just show us, okay, it has been detected around 6 lines in here, showing all the start and ending point of all of them. Lastly, I'm just going to simply take the image, okay, or the image, which is again blank image with all the lines on it. I'm just going to put it on my image, which is on my original image. Simply put, just to show my lanes, and if we're going to detect, for example, 2 red lines or something, that will indicate my lanes, just like for display purposes. So I'm going to use cv2.add weighted, okay, which is again very simple technique that you can just use within OpenCV. We're going to provide image C, which is again my original image, which is on top here. That's my image colored, okay, which is this image. I'm just going to take it. All right, and then what I'm going to do is I'm going to again use alpha. I'm going to use my line image, which is the image with the lines on top drawn. I'm going to use beta and use gamma. What are these values? Here I try to include the equations just for you guys to understand what's happening. Simply put, I'm just going to use the original image multiplied by a specific factor. And then I'm going to use my second image, which is the line images, multiplied by a certain factor. And then I'm going to use gamma value kind of, as a factor to add or subtract values from the pixels. Simply put, I'm just merging these two images together, and then I'm going to plot it after. Let's run it. and let's run it. And that's it. Very interesting. So that's pretty much, if you guys can see on my image, now I can detect specific lanes within within my image. If you guys can see, it looks pretty interesting. And you guys again can go up here. You can change, you know, you can change any of these parameters and see if you can detect, you know, lines more accurately. You can detect maybe shorter line. Maybe you can increase the region of interest and try to detect this line for example. And then, you know, obviously what you could do moving forward, you can use this image instead of actually having an image. You can put all of what we have written here in a function, okay, and use kind of, instead of applying a photo here, you can use a video stream, which is pretty much the same, exact same idea. Video stream is simply just one series of images. So we're gonna take all this, put it in a function, and simply call it several times. Every time, take an image and send it to the function and draw lines. Go back and keep doing this, kind of what we call it pipeline. Then you can develop your own pipeline to actually run it in real time if you wanted to know or indicate where your lane is. Once you know your lane, then you can center your vehicle, and then you can start to detect objects moving forward. We're gonna cover that moving forward. We can detect traffic signs and so on and so forth. All right. I hope you guys enjoyed that fun project. I hope you guys enjoyed it, and see you in the next section.